To part 7 of Competency 14. In this video, we will work with matrices and vectors. In this quick little clip, we are showing you how all of these reflections, rotations, and slides would work with an image. If you see down at the bottom, you'll see labeled A of our little mascot, our little white kitty cat. That image A is the original. And then if you look above that, above where the x-axis is, you see that A is copied. And then you have a copy of a copy in all these different ways. As the video moves, you'll see how the image is transformed and moved around. It's just a neat way of seeing it. Now, for testing purposes, at this point, since linear algebra generally isn't taught at the high school level yet, I'm hoping it will be. I hope I see that in my lifetime. So anyway, it just gives you an idea of a way to show your students what this means in the digital world. Displayed is an updated version of the table that we'll be using throughout the video. You might want to take this opportunity to take a little screenshot of this. Okay. All right, number 1, if point -35 is translated to point -87, what is the translation matrix? Okay, so what we need to do here is first let's consider this matrix A. This is going to be matrix B. So in the spirit of things, we need to say that we have A plus this I don't know matrix equals B. And that will be an X and a Y. Okay? So naturally, we can subtract. So we take B, okay, and I'll state this better. Okay, let's state it down here. B minus A equals our unknown matrix. Okay? So this means we need minus 8, 7. Subtract from that -3 and 5. Okay, we don't need to put this in the calculator. You can to double check it, but at this point it's faster just to do it by looking at it. So we have -8 minus a +3. Well, that's -8 plus 3. And that gives us -5. Okay, and then we have 7 minus 5, so naturally that would be 2. That is, of course, option B. All right, let's move on. Number 2, if point 82 is reflected across the y-axis, what is the reflection matrix? Yes, I'm sure you're looking at it saying, okay, you just gave us a table, so I know what the answer is. Well, the point of this question is also not just, do you know it? And you're not going to have a table when you take the test. Can you think it out without the table? Well, sure we can. The first thing you should see is option A. That's not going to work because that is the identity matrix. Okay, so that can't be it. Yes, we're going to consider B. That should be it. Okay. Well, what should the final answer to each of these be when we multiply it to our matrix? Okay. So if we take and multiply 8, 2 to each of these, what are we going to get? That, by the way, I'm kind of shortcutting. That does not mean absolute value. Okay. I know that's one thing. A lot of people just write the straight lines. Technically, that's absolute value. Okay, so when I shortcut, please forgive me my shortcuts. Okay, so we have 8, 2. Okay, and what should our end result be? We are reflecting over the y-axis. This means that our new point, our prime, would be -8 and 2. This will be our prime. So then the only change is this -8, which is our x value. Okay? So when we put these in the calculator, what actually changes? Or if you just sit and look at it. Okay, I'm going to show it in the calculator and also talk about it. But we can, if you've done this type of matrix in your head and you've worked out element by element, you know how it's going to come. I mean, it's not hard to see. But just in case you're not used to this, let's look at what's going on here. C in our table, C's a rotation. Okay, and so is D. Okay, if you look at the table, they are the last two in the table, and C is rotating counterclockwise, and D is rotating clockwise. Okay, so let's take a look at our calculator, and let's do that. So second matrix. Okay, we need to edit A. So it's highlighted, and we need to make some changes. Okay, so enter, we need -1, enter 0, enter 0, and enter, and then 1, and enter. Okay, so back out, second mode. Okay, now second matrix, and let's alter B to be our 8, 2 coordinate. Okay. Oh, nope, I forgot to go over to edit. I make that mistake more than I want to admit. Okay, second matrix. Okay, now let's go to edit. Let's do it correctly. And go down to B, number 2. Okay, enter. There it is. Okay, it's a 2-1 matrix, so we put in 8, enter, and 2. That's our starting point. Okay, now go back to second mode. Second matrix. Now we can just push enter. Push. We have it highlighted on A, and we need A times B. So this is our A, and this is our B. Okay? So push enter times second matrix. Go down to B. Push enter. Enter again. And we have the correct item. So we know that option B is going to give us that. Oh, if I could improve on my writing with my digital pen. There it is. Okay, just takes a second. So that's -8 and 2. Okay, so at least we knew we did that correctly. Now, we could put this back in the calculator, but let's go element by element. It's actually going to be faster. So what am I saying when I mean that? What I mean is we have 0 times 8 is 0. Okay, and then we have -1 times 2 is -2. Oh, I spoke too soon here. It's a -2. Okay, and that will take care of my x value. Now my y value. Well, I have 1 times the 8 is 8. Now that's plus 0 because it's 0 times 2 plus 0. So that result is -2 and 8, which is not what we need. That, of course, would rotate, so it sends that somewhere else. Okay, not what we're looking for. Now let's look at the next one. That will be 0 plus 2, okay? Then -8 plus 0. And that result will be 2. Oops, that should be a 0. That will be -8. Again, not what we're looking for. We needed -8 and 2. So that shows you how it would look and how to check it. You can put that in your calculator and check it, but kind of wasting our time. You can stop the video and try it for yourself. All right, so let's look at number 3. All right, now we're going to use the graph continue to use this graph above to put in number 3. If point -1, -2, let's put that in. That's right here. Okay. -1, -2 is reflected across the line y equals -x. What is the reflection matrix? Select all that apply. Okay, so what we have is a line going down, negative, just like that. Okay, so if we reflect this guy, he will be over here. It will be instead -2 and 1. Yes. And then we can see what's happening from here to here and here to here. Okay. See how it's kind of if we're thinking of it as a vector, what's happening. Okay. Now, also, you can also think of it as being perpendicular to the line that it's crossing. I mean, either way, you can see the process. Now, here's the thing. We have several options. It's much more than what we usually would see, and we need to select all of them. Well, the first thing we can do, you can look at your table, and you could also try this out in your calculator to verify to help yourself out. We know that our end result needs to be 2 and 1. But for this situation, let's look at our table. We know that A is not an option because, again, this is a rotation, and C is, again, a rotation. B, however, let's see, what is B? It reflects, it's saying on our table that B should be what we need. Okay, that's all well and good. But what about these other guys, D, E, and F? If you look at your table with that reflection in the center column, we have our trigonometric, and that's what we need. And that is saying that we need to look for, if you notice on B, we have negative here and negative here. And which of these outcomes do we have that on? Well, I see that on B and D and E here and here. You know what? Let's go to our calculator and double check that. The first thing we need to make sure that our calculator is still in degrees. So let's check mode. Okay. And it isn't. It's in radians. Okay. So let's go down and over. Double check that on your calculator also. Okay. Now it's highlighted in degrees. Great. Now go second mode. Well, now how do we verify that this is what we want? Well, that's easy enough. Second matrix, go to your matrix, go to edit. Remember, matrix A, we have as a 2 by 2. That's what we're using, so push enter. And go to the first cell. And in the first cell, I'm going to work with D first. We should have a 0. So what do? Cosine 270, push enter. And that is a 0. Now let's try negative sine 270. Negative sine 270 and enter. And that's a positive 1, not a negative 1. Let me go back and make sure I did the negative part. All right, let's see. Negative. Okay. Sine 270. Close, enter. Nope, that won't work. So that option doesn't work. Oh, okay. This one will not work because of this negative. Okay. Now, that being said, what about our 90 degrees? It might make a difference. Well, let's go back up in each cell and check it out. Well, we already know cosine 270. What about cosine 90 degrees? Okay. Push enter. Well, it is 0. Interesting. Now, let's say negative sine 90 degrees. And let's enter. It's -1. So 270 and 90 made a big difference. So obviously, in the next cell that we have highlighted, it should be exactly the same. So negative sine 90 degrees. Absolutely. And again, we know cosine 90 degrees will yield that 0, and it does. So that all checks. All right, so far we have B and E, but let's look at F. Now, from what we just did, we know that this will not work. So F cannot be an option, okay? So we have two options that actually satisfy. Number 4, what is the glide reflection matrix for the point -1, 3 that is translated by the vector 2i plus j, then reflected across the x-axis? Okay, has two parts. The first part we can just do by hand, and then let's move to the second part and discuss it. I say that because our options, our A, B, C, D options, actually are showing the second part. Okay, so we should know that this is 2, 1 as far as our translation matrix, okay? So then we have that. We're going to add them together, but how do you do that? That means that you place the minus 1, 3. Okay. All right, there we go. Minus 1, 3 first, just for safety's sake. And then we will add those together. And I can see really quick that -1 plus 2 is 1, and 3 plus 1 is 4. Okay, right? So this eliminates options A and B, regardless of what the matrix is. We'll call this A. Regardless what the A matrix is, sorry about that, okay, it won't work. Okay, why? Because this is actually our translation matrix. So that would be with step 1. And then the results, of course, aren't even what we need for step 1. Okay, so let's evaluate the next one. Let's see here. We need to, oh, this looks like a rotation because it says reflect. Okay, from our table, I'm thinking that C won't work and we have to select D. Okay? All right, well, our part 2 here, this is correct and this is correct. Let's put it in the calculator. Either way, if I draw this out, I'll just sketch it out really quick. We are starting with 1 and 4 right here. Then we're going over the x-axis. So that means, and pretend like my y-axis is actually straight. We do a lot of pretending in these videos. That means that my end result should be here. And that should be at point 4. That should be 1, -4. All right, let's put that in the calculator and see what we end up with. Okay. All right, so second matrix. Let's go to edit, make sure we have the right thing in, and we do not. So we need to enter, we need 1, enter, 0, enter, 0, enter, and then a -1. Okay, we're looking at option D here. Okay, and that is incorrectly. Now, we need to change our B. So we're going to call this A, this one B, and we will multiply them together and we should have this correct result. Okay, let's back out of that. We go second matrix. Now we're going to edit B. and we need to have 1, 4 in there. Okay, 1, enter, 4, enter. Great, now back out. Okay, second matrix, I need A times second matrix, go down to B, enter, enter again, and that is correct. So we have verified that option D is correct. Okay, now let's talk about number 5. If a point is rotated clockwise about the origin, what is the rotation matrix? Now, this is different. We have a situation that has a sine with a pi over 2. Well, that's radians. So we have a mixture of answers with radians and degrees. Well, either one could be correct. Okay. So what do we need to do? Well, first, we could go to our table and take a look. Right? It says clockwise. So if you look at your table, okay, and this tells you that you probably need to do a little more work with the table and get it memorized. So it wants to go clockwise. Well, what does that mean for us? That means that we need a negative here. Okay, and A is the only item that has a negative. So let's just check that. Let's check it in our calculator. Okay, second and matrix. Let's go over to edit. And you're like, well, how can I check that? Oh, you know what? Before we check it, we need to go back to radians. I believe we are in degrees. Well, let's check that. Let's see if we're in degrees. Just for grants. Let's go to this one and say cosine 90 degrees. What happens? It pops out a 0. Okay, let's go back. Okay, let's see what happens. Let's say cosine second pi divide by 2. Watch what happens. Yeah, that could lean towards a big mistake. All right, so we need to go second mode just to get out, then go back to mode. And let's put that in radians because remember, we're checking option A to verify. See, it's highlighted, second mode. Now let's go back to my matrix, second matrix, over to edit, edit A. Okay, now let's go back. Now let's put in cosine second. See our caret up? Now let's divide by 2, enter, and it is 0. Okay, now let's try sine. Sine second, caret up. I say that because that's what it's called. And then above it is the pi, if you haven't noticed, and divide that by 2, and we get 1, which is perfect. Now here's the moment of truth. Will this work? Let's put negative sine second, caret up, divide by 2, close, and yes, it does. So there you go. And I'll go ahead and finish that out with cosine, right? Second, caret up, divide by 2. And if you notice, I like to close my parentheses. And it is fully correct. It matches what we have. And of course, if we put the others in the calculator, you would see that they would not be the correct one, right? So that gives us that option. Oh, look, cool. Highlight it instead of doing oh no, and it copied. Oh, there it goes. Wow, that was interesting. Okay. Number 6, if the point 7, negative 5 is rotated 90 degrees counterclockwise about the origin, what is the rotation matrix? Okay, how do we deal with this? Well, first thing, verify that we have the correct uh, original matrix or XY in here. So make sure that their original is all correct, and they are. Now we need to look at what we have. We are rotating 90 degrees. And one thing that you should have noticed right away, that when we rotate, we should have in these two positions, there should be at least a 1 or a -1, okay? So what does that mean for us? Well, C's okay. That means B and D are not going to be an option. They will not rotate, okay? Now that, oh no, and A will not either. Oh, I don't know why I didn't say that. So A doesn't either. So that kind of like tells us we're left with C. Let's check it. First off, sketch it, then check it. So let's sketch and check. Okay. So I'm going to say, let's say 5 is here and 7 is here. Oh, no, 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 no. That would be the other way around. Okay, I probably will end up writing that again, but I need to say, let's see, it is 7 and -5. More like this. That looks better. Okay, 7, -5. So if I rotate that 90 degrees, what would that look like? That rotation would look more like this. Okay, and it would be more this way. So what is that going to give me? That is going to give me 5 and 7. Well, both results must be positive. Well, if we look again at these options, this does not work, this does not work, and this does not work. That verifies again that we're on the right track. Let's put it in the calculator and test it out, okay? And it's a rotate. If you look at your table, you see, yes, we are correct. It's perfect. But we're already set up here with our 2 by 2. So let's put -1 in. Okay, and then just put a +1 and back out. Let's populate our B matrix. Go to edit, go down to B, enter, and we need to say 7, enter, -5, enter. So our B is there, back out. And you know what I'm going to do? I'm going to bounce up to where we have A times B. And I'm going to bring it down and enter. Save myself some time. And it is the correct result. So C is our option and we're done. Okay, that's our last question in this video. And once again, thank you for watching and putting up with all the things I have to say. And also, share us, like us, please subscribe. Happy testing!